Suddenly one day you call them was after everybody started Chinese Well, you can make cash for your no more Ryan anymore. Tell us Ryan. Tell us Ryan.
All right.
Ryan. You did try it, yes.
Well, I can learn this too.
Oh, you did go to school?
Yeah.
Why?
You always know about that.
Really?
That's right. Please.
Yeah. You don't know. Oh, yeah. I mean, it's fine, it's COVID now. It's like the COVID.
Who cares, bro?
The US do the weed. Yeah, I guess you test. Yes, yeah, you just every week. See, he does it. You don't do it. I don't. I don't. Yo. I would have done it. It's so many. Then you're not gonna speed it.
Nah, bro.
No.
Ah, shit, my fault.
Wait, what is the last example? What? Electrical engineering. Electrical engineering. I have to prove offensive.
Yeah. Oh, yeah, recruits got calling, so. Interview for
Cambridge. Oh, you read it. You read it.
really good.
Game was so sad. Cambridge is you go for mathematics. I thought I should have done it. Somebody gave it to me.
That's true.
So, company man, and then.
Yeah. Oh, wait. Is it?
What is it? You
just came. You play your test for y'all,
bro.
Bro, that was pretty before, bro. Hey, Lorena. Lorena.
Okay, class. So let's see. Start.
You better tell the dessert.
Yeah.
You take. You have Kevin after this?
Test.
I think you have Kevin.
Wait, are we discussing feedback today? No. Usually Wednesday. Oh yeah, I can say yeah, we're gonna do
Okay, class. So last part of this topic 14, medical. So we learn about ultrasound, X-ray, CT scan, and last one, PET scanning. Okay, so okay, PET scanning, positron emission tomography, full name. So as I said, all machines except ultrasound all looks like this, like a donut shape. CT scan, X-ray, just a tube. CT scan, MRI, PET scan will be the same shape. The machine. So positron is used to do this scanning. One of the antimatter. Okay, used. This is the objective. Yeah, so the type of nuclear medical procedure images tissue and organs by measuring the metabolic activity of the cells of the body tissues. Actually, to be summary, PET scan used to detect especially cancer cells, mainly used for cancer patients. If the doctor suspect or after they diagnose cancers, they after we went for treatment, after 6 months later, they want to check if there spreads, is there any left in the body, they go for PET scan. So yeah, so a type of nuclear medical procedure that images the tissues, organs by measuring the metabolic activity. Normally, metabolic activity means cancer cells will have a very high metabolic activity. So by injecting this radioactive substance, they can detect the location of the cells which has a very high metabolic activity, which is the cancer cells. What is the uses? Of course, detect cancer, make a diagnosis. Whether the cancer has spread in the body. Okay. They might have a colon cancer. Then surgery, they remove part of the colon. And after that, after 6 months, they want to check. Okay, is it spread? Okay. So this test can tell is it spread any part of the body. Okay. To determine whether the cancer spread in the body, they use this PET scan. Okay, effectiveness of the treatment, determine the cancer has returned after treatment. Mainly the fourth one, evaluate prognosis, tissue metabolism and viability and so on. Brain abnormalities such as tumors, seizures, they use that. Nervous disorder, but mainly cancer. Okay. Yeah. Actually, positron is used. Positron going to react with electron in the body. Positron is the twin brother of electron, right? Electron, positron, what's the difference? Everything is identical, only the charge is opposite, right? So when the electron positron, something called annihilation. Heard of annihilation? Annihilation. Annihilation is actually when the two mass combine, matter and antimatter combine, what will happen? Matter and antimatter mix up, what will happen? Annihilation. Annihilation is the process of what? Mass convert to energy. They destroy, mass destroy. It's a mass destruction, not a weapon, mass destruction event. Mass is destroyed to become energy. So the energy convert to a gamma photon. It can become a gamma radiation, gamma photon. The body inside will have a gamma radiation surface. The gamma radiation will be always in opposite direction because momentum is conserved in each direction. So the gamma radiation, which is traveling in opposite direction, will be detected by a detector surrounding. It's a gamma detector. Okay. So the point where the detector detected, they draw a straight line so they can point where which point the emission of gamma happens. So it means that point, why that point the emission happens? Because that's the point where the electron positron has meet up. Okay. Why? That means that's the cell which absorbs the positron. Okay. Not all cells will absorb the positron. Only certain cells, the cancer cell will absorb the positron a lot. Okay. We will discuss why. Okay. So this is a rough idea. Positron and electron combine form a gamma radiation. Okay. This process called annihilation. Okay. Mass destroyed tend to become energy. Okay. The principle of PET scan, a small amount of tracer, sometimes referred to as a radio tracer, is injected into a vein. Okay. So of course, cannot do frequently. Maybe once in a year for a cancer patient. Okay. Because you are injected with the radioactive substance into the body, and of course have a reasonable short half-life, 2 hours maybe. It travels around the body and absorbs by organs and tissues. So this radio tracer will be absorbed into your body and absorbed more by the cancer cells, because they are quite active. The radio tracer's job is what? Enter into the body, spread into the body, release positron. Okay, it releases positron. Okay, throughout the body. Okay. That positron analyzes the nearest electron. Actually, as I said, the radio tracer is more absorbed to the cancer cells. So when it comes up from the cancer cells, it's going to react with the electron. Two gamma radiation traveling in opposite direction is produced. So yeah, and annihilation. Annihilation means the process of mass convert to energy. Okay, mass destroyed become energy. Okay. I think previous class, the other class I told last time when I do AS, you know, the Star Trek, like the Enterprise using matter and antimatter, right? Okay, for the fuel. Okay, when the matter and antimatter combine, called annihilation. Okay, the energy going to be a lot when antimatter and matter annihilate, right? How many kilogram of uranium was used in the atomic bomb dropped in Hiroshima? About 67 kilogram, I think. Bomb dropped in Hiroshima. But how much of antimatter is enough to make the same effect? Just half gram. Half gram of antimatter is enough to give the same effect as the about 67 kilogram of uranium. Okay? So the energy is tremendous when annihilation happens. But this is not a big nuclear bomb, just a very small amount. Okay, the radiation from the strike, the detector, and the line of response is established. where the two rays are coming out will be detected by the detector. The point at which the interaction took place is determined by the arrival time, the arrival of the gamma. The gamma should reach roughly about the same time to the opposite detector. That means they know these two gamma is originated from the same annihilation. Okay? Because multiple annihilation happens at the same time. So they want to know which gamma is paired with each gamma, with the time difference they've done. The time difference must be very small, because when annihilation happens, they should reach the detectors about the same time. Okay. So point at which the interaction took place is determined by the arrival time. Okay. Let's say one gamma received after another gamma received 1 second later. These two they won't expect is the pair. Okay. Another one is just few milliseconds after this first gamma, they might think this two is the pair from the annihilation. Okay. Yeah, okay, so as I said, so yeah, this is the cancer cell annihilation happens here, gamma radiation appears, detected here and here. What they'll do, they detect here and here, then draw a straight line, the software does that, draw a straight line, this is the location. These are the locations of the, what you call, cell can be. Okay. You might get another one here, right? So the intercepting can locate. That's the cancer cells. Okay. So detector forms a series of rings around the patient. The gamma photons travel from point in a straight line in opposite direction and strike the detector. Shown. A line called line of response. Can be drawn joining the two detectors using the time lapse between the two photons surrounding the detector. The position of the line of response can be established. Then practice, lots of annihilation happens. Sophisticated computer analyze the data, convert into an image. Okay. Not only one, a lot of annihilation happen. So the computer can detect each point and it gives a different color to that area and produces the image where most likely the cancer cell could spread it. Okay. So part of the detector is called crystal scintillator. And the gamma ray photon is incident on the crystal. The vector of crystal is excited to higher energy level. So the detector is made of again like as a crystal, and the photon go and strike the crystal. The crystal electron will go to the higher excited state, like happen in X-ray. Okay. So when they go down, they releases energy. Excited electron travel through the crystal, excites more electron. And the excited electron move back down. Original state, the loss of energy transmitted a visible light photon. Okay. This particular crystal, ultrasound crystal, that vibration mode is ultrasound. But this crystal use the energy differences in the visible range. Okay. So when the electron goes down, it gives out light. Okay. In a visible range. Okay. Like fluorescent. Okay. So when the excited electron moves back down, the original state, the loss of energy is transmitted to a visible light photon. And this photon is not very strong, very weak photon. So it gives out a small, what do you call, a small signal, very small signal. Like, you know, heartbeat connected to the electrode to check how the heart is beating. The sound of the heart is converted to electrical signal. The electrical signal is very small at the beginning. Then what they will do, the electrical signal will be amplified by using an amplifier. Then it will be shown on the CRO. Okay. So the original signal is not that strong for the heartbeat. It needs to be amplified. The same thing in the scintillator, the photon produced, the light is not that strong. Okay. The light is quite low intensity light, you can say. But the crystal scintillator function just produce that the low intensity photon first. Then it need to be amplified. The photon will be amplified by using what? By using something called photomultiplier. The photons produced by the scintillator are very thin, so they need to be amplified and convert to an electrical signal by a photomultiplier tube. And this signal will be used by the computer to generate the image. Okay. Okay, so that's a rough part of the idea. Inject with the radio tracer, positron find an electron, they annihilate, gamma radiation produced, gamma radiation will be absorbed by the scintillator, the electron inside the scintillator excited, okay, excite more electron, the de-excitation happens, release photon, the photon is very faint, will be amplified with the photomultiplier. Okay. Okay, now we go a little depth about radio tracer. Okay. Okay, a radio tracer substance that can be absorbed by tissue in order to study the, of course, the function of the organ. The example of radio tracer currently used is technetium and fluorine. It's 99 only, or fluorine 18. Okay, why these two used? Because this radio isotope decays into beta positive to produce a stable isotope. So at the beginning, the substance is radioactive and enters the body. Once you release the beta emission, the substance, the outer nucleus is stable, so not really harmful for the body. Okay. So yeah. But during the 2 hours, you will be radiating gamma radiation, the body. So yeah, the half-life is we want few hours for the scanning to be done. 6 hours, less than 6 hours. Fluorine is just 2 hours. So yeah, 6 hours, 2 hours. So you know, we can't have too long half-life, dangerous. You will be radiating for 1 day if you got half-life, like one day. Both bind of organic molecules such as glucose or water, which are readily available in the body. Okay, this radioisotope will be bind into such a glucose or water. Okay, a solution will be mixed with this radio tracer first. Okay, so make the radio tracer to replace a molecule inside the glucose and inside the glucose actually. So the fluorine like hanging in the glucose. Okay, replacing someone is temporarily made a bond with the glucose. Let the glucose enters into the body. Let the glucose absorbed by the cancer cell, and the fluorine emit the beta radiation and reaction to happen. Okay. You know the reason why, right? So unnecessary radiation. So allow for short exposure time to the radiation, of course. Okay, a short half-life does mean the patient need to be scanned quickly here. Not all hospitals have the access expensive PET scanners. So we need to done the scanning quickly because only 2 hours of half-life. Okay, and to increase the number of main reason why, of course, less harmful for your body. Second advantage is do the scanning fast so that more patients, because not all hospitals have these PET scanners. Okay, expensive and dangerous. Okay, yeah, these two reasons. Okay, why you use short half-life. Okay. So a little bit about annihilation. Roughly, I told you mass convert to energy. So when a particle meets equivalent antiparticle, they will be destroyed, tend to become energy. Okay. That's the treated by scientists, right? Big Bang. Big Bang. Next topic. Formation of universe. Big Bang happens due to energy reaction of energy. Great mass. Okay. So mass and energy is interchangeable, right? From the nuclear topic. Okay. So annihilation means mass convert to energy. Only happens when the correct twin brother was the correct antimatter meet up is matter. Okay. The only one circulating now for us human identification, what we identify is only positron currently. But they said all particles has its own antimatter. But we couldn't find one yet. Yeah, so during this is a nuclear process, right? Annihilation is actually a nuclear process. Okay, that's destroyed. So nuclear process means you should recall what are the things conserved. Of course, during annihilation, mass energy is conserved, momentum is conserved. Of course, nuclear number, proton number is conserved. But our constant here now, our discussion is mass energy and momentum is conserved. Okay, the annihilation in PET scan. So when a positron is emitted from the trace in the body, travels less than a millimeter before it collides with an electron. So yeah, the positron and electron annihilate, their masses become pure energy in the form of two gamma rays, which move apart in opposite direction. Why opposite direction? Momentum conservation. Yeah, principle of conservation of momentum, right? So yeah, they have to travel in opposite direction. So just in case, because this is something new for your syllabus. You are the first clinics going to sitting for this PET scan. Okay. So the question going to come out, we think we predicted only facts like what do you call explain the principle of this scan. Okay, as ultrasound. Okay, sound sent into the body, every layer reflected, time tells the PET, strength tells the nature. So we think like that kind of question expected, okay, most of the time. But calculation so far, the only calculation which other bots doing is calculating the energy of this photon. Okay, other bots, IB. So I just introduce you a little bit about the energy, just in case if they ask. If they ask what is the energy of this photon gamma, so how are you going to calculate? How much of energy of this photon gamma photon? So what formula do you use? MC squared. Use MC squared. The MC squared of both these two electrons, okay, the MC squared of this plus MC squared of this is equals to 2 times of the 2 of the gamma photon energy, right? Yeah, MC squared plus MC squared equals to 2 gamma. So divide 2, you get the gamma energy. You want to get more energetic gamma radiation, this electron fired with kinetic energy. Okay? Let them collide with possessing some kinetic energy. If the electron has kinetic energy, then the gamma energy will be much more higher. Why? Not only MC squared convert to 2 gamma, MC squared plus half mv squared. The electron also will convert to 2 gamma. Okay. So this is least expected. I don't think so, but other bots they are calculating the energy of the gamma. Okay. So just in case, if they ask what is the energy of the gamma, MC squared of the electron, MC squared of this electron equals to 2 gamma. Okay. One assumption made for this calculation is what? No, the kinetic energy of the electron initial collision is negligible. Okay, negligible. Okay. So if it as a significant kinetic energy means that will affect the energy of the gamma. Okay. So mc square plus mc square is 2 gamma. 2 gamma. Okay, the nuclear reaction, same thing happens. Nuclear, the cloud chamber, they accelerate two matter antimatter with a high kinetic energy. They see the track in the cloud chamber because they are charged particles. They see the track, they are colliding. After that, empty, nothing happens, no track at all. Suddenly a two track happens. Okay, so what is happening? What is happening? They found a two track first. The matter antimatter colliding. Then suddenly nothing, no track at all. And after a short distance away from the cloud chamber, they found another two track appeared. So what is happening? The mass annihilation happens, tend to become photon. Okay. Then the photon, after a short while later, the photon creates mass back. The photon creates mass back. Okay. Energy convert to mass again. So when energy convert to mass, what it produces? The matter antimatter produces energy. This photon sometimes can create mass back. Okay? So when it creates mass back, what it produces? Equal number of matter and antimatter. It always produces matter equal antimatter. They have to when energy convert to mass, it always produces equal number of matter and antimatter. Okay. So here, the gamma, we never allow gamma to convert to mass back yet because quite short distance. But this can change to energy later. When they form, they can change to become mass and antimatter. Okay, equal amount. Okay. So energy of a photon, the mass energy is conserved during the annihilation. The mass of electron is 9 times 10 to the power negative 31. Is converted to the energy of 2 gamma photon. So the equation of mass equation is half mc squared. Sorry. So the equation of photon is HF. So yeah, general HF equals to mc squared. Actually, 2 mc squared equals 2 HF, right? So 2 cancel. Yeah. HF equals to mc squared. Frequency of the photon can be calculated. Yeah, so in PET scan, so the electron positron converted to 2 photons. Please include here kinetic energy. The initial kinetic energy of the electron is negligible. Okay. Kinetic energy, we are assuming the kinetic energy possesses negligible kinetic energy. Okay. Okay. So actually that's all. Okay. This is what expected to memorize. Okay, PET scan. On top of that, calculation is the energy of the photon. Okay. Find the frequency of the photon or energy of the photon. mc squared equals to HF. Okay. The most they can ask in this topic. But expected, the principle behind PET scan. We are expecting around 6 marks. This comes up. Okay. You are the first batch. Something new. So highly expected for your paper. So yeah, chlorine atom of trace is injected to a glucose molecule, attached to a glucose molecule. The solution is injected into the patient body. Cells which are highly active, such as the cancer cell, absorb the glucose molecule. right? A cancer cell is the most active in the body. Anyone diagnosed with cancer cells means the cancer cell takes all the energy, most of the energy of the body. So for them to grow, okay, they grow actively. The cancer cells never listen to the brain instruction. You just grow. So it absorbs glucose, energy of glucose. Okay. So cells such as cancer cells are more active, absorb more glucose molecules. Second one, they have 18 atoms decays into positron. Positron empty particle of electron meets electron, and annihilation happens. Keyword annihilation happens. So the mass converted to 2 photons travel in opposite direction due to conservation of momentum. Okay. The patient surrounded by a ring of gamma detector. 2 photon detects simultaneously by 2 detectors in the detector rings. The location of annihilation occurs along the line of response. Many annihilation occurs in the computer uses Lyell pattern of the gamma photon create image basis concentration. So, this is the line of response there. So you detect here one, you detect one. To draw a line. Yes? So most probably here where the cancer cell lies, let's say this is structure. Another one here and here. So draw a line. Most probably the meeting point should be the location where the active cell, most likely cancer cells. So actually, when they do the imaging, the light will be emitted from the region where the computer detects the light which is emitted. So if anyone go for the scanning, let's say the brain got a small light, that means there is some cancer cells in the brain. So to check spreading actually, how much spreads cancer cell after the treatment. So that's all. Let me show you a lot of videos. One video first. 1 minute. Speaker.
A PET scan creates 3D images of the body. It does this by using radioactive tracers, which are usually administered to a patient through intravenous injection. The tracers are made up of carrier molecules that are tightly bonded to a radioactive atom called an isotope. The carrier molecule can interact with or bind to specific proteins or sugars in the body.
Sorry.
A PET scan creates 3D images of the body. It does this by using radioactive tracers, which are usually administered to a patient through intravenous injection. The tracers are made up of carrier molecules that are tightly bonded to a radioactive atom called an isotope. The carrier molecule can interact with or bind to specific proteins or sugars in the body. The carrier molecule that will be used depends on what the doctor is looking for. If she suspects cancer or is monitoring a known cancerous growth, she may use FDG, a modified form of glucose, which gets absorbed by tissues. When tissues absorb a lot of glucose, it may indicate a cancerous tumor. The radiation from the tracers poses little danger to the patient since they quickly pass out of the body. The isotope produces small particles called positrons, which interact with surrounding electrons. This interaction results in the complete annihilation of both particles, releasing 2 photons that speed off in opposite directions. The detectors in the PET scanner measure these photons and use this information to create an image of the distribution of FDG in the body.
Get another one. Another one. This one. Okay, so not again like history, a fact to remember. Okay, so this topic, ultrasound, CT scan, X-ray, and PET scan. The only subtopic which gives you difficult calculation, of course, ultrasound. The depth. Okay. X-ray can give you some calculations too. What X-ray can give you calculation part? Which one? The minimum wavelength. What is the shortest wavelength? How do you calculate? EV equals to HCO lambda. That for X-ray. Okay. For CT scan, purely facts like PET scan. CT scan, no way they ask. Actually, they are calculation last time, counting the pixel, but now they removed it. Okay. So CT scan purely facts to remember. And PET scan also looks like 98%. We are predicting principle they should ask. Okay. Calculation means photon energy are expected. Photon energy. Okay. Any questions? So for topic 14 overall, not as demanding as quantum. Quantum is more theoretical, more calculations. This one is less demand for the calculations. Okay. Okay. So that's all. Okay. I will be. Okay. Now another one thing. Your test. Your test. Okay. You got your papers right. And check on the time. Okay. Majority make a mistake with the 2 wires 4 marks question. How they attracted. Okay. So of course current carrying. You can imagine like 2 wires carrying a current in the same direction. Okay. So many of you, what is expected in the mark scheme is the Newton's third law. Okay. We expected Newton's third law to explain the attraction. Okay. So what do you have to tell? The wire A, wire B, they have said when current flows, magnetic field is produced by the wire 1, wire A. Then you have to tell the magnetic field of A is overlapping in wire B. Okay. Therefore, by using Fleming left-hand rule, wire B experience force upwards towards A. So most of you say that. Okay. Then, how it does the wire A experience force using to Newton's third law. Based on Newton's third law, wire A will experience the same magnitude of force as B, but in opposite direction. That's the answer expected. So that's the main part. Majority of you made a mistake. Okay. 1 or 2 of you got it good. Okay. So we're done with this. Tomorrow we'll be doing the new topic, last topic, astrophysics. I'll post the notes. I haven't posted yet. Today I need to do something, so I posted today. Okay. So tomorrow we start the astrophysics. I think by Thursday or Friday I will be finishing. Okay. I believe at the background you are doing the papers. Maybe out of 12 questions of your paper 4, you should be, now you are practicing the first 10 questions maybe, okay, consistently. Okay. So next week we'll be discussing the papers or whatever questions you have, any papers, trial or, so bring up, so next week we'll be discussing, okay, the papers. Okay. Any questions? No questions. Okay, so I stop here, not much to say. Okay.